Welcome to Big Data Now. Today, we're diving into a hot topic in the machine learning and big data space, PyTorch versus TensorFlow. These two frameworks are the most popular tools for building and deploying machine learning models, but which one is the right choice for big data applications? In this video, we'll explore key differences in their performance, features, and scalability, how they're used in real-world big data projects. By the end of this video, you'll have a clear understanding of which framework is better suited for your big data and AI needs. Let's jump in. Let's start with a quick overview of what these frameworks are. PyTorch is an open-source machine learning framework developed by Facebook. It's known for its dynamic computation graph, which allows developers to modify models on the fly during runtime. This flexibility makes PyTorch a favorite among researchers and those experimenting with cutting-edge models. TensorFlow, on the other hand, is Google's open-source machine learning platform. It's designed for end-to-end machine learning workflows, from model building to deployment. TensorFlow introduced static computation graphs initially but later added dynamic capabilities with TensorFlow 2.0 to compete with PyTorch's flexibility. So, in summary, PyTorch is ideal for experimentation and research. TensorFlow shines in production-ready pipelines and scalability. Now that we know what they are, let's look at how they differ in their application to big data projects. 1. Data loading and preprocessing. Both frameworks provide excellent tools for handling large datasets, but there are differences. PyTorch uses the DataLoader and dataset classes, which are intuitive and customizable. These tools make it easy to load massive datasets, even from distributed file systems like Hadoop. TensorFlow offers the tf.data API, which is highly efficient for streaming large datasets in production environments. Its pipeline approach can be more complex but is optimized for high performance. For example, here's how to load data in PyTorch. And here's how you do something similar in TensorFlow. While PyTorch offers simpler syntax, TensorFlow's tf.data API is more optimized for production pipelines, especially when handling distributed data across large clusters. 2. Model building. In PyTorch, model building feels more like writing plain Python code. This makes it easy for developers to experiment with new ideas. TensorFlow, while more complex, offers advanced tools like Keras for high-level model building. Here's an example of a simple linear model in PyTorch. And here's how you do the same in TensorFlow. Both frameworks are equally powerful, but PyTorch's model building process feels more Pythonic, while TensorFlow's high-level APIs make it easier for beginners. When it comes to performance, TensorFlow often has the edge in large-scale production environments, thanks to its integration with Google Cloud and TensorFlow Serving. TensorFlow's optimizations allow it to handle massive datasets efficiently, especially in distributed training scenarios. However, PyTorch has closed the gap significantly with the introduction of TorchScript and PyTorch Lightning, which make it easier to deploy models in production. PyTorch is also praised for its debugging capabilities, as its dynamic computation graph integrates seamlessly with tools like Python's debugger. For example, distributed training in PyTorch can be done with torch.distributed, while TensorFlow uses tf.distribute strategy. TensorFlow's solution tends to be more polished for large-scale systems, but PyTorch is rapidly catching up. Both frameworks are widely used in big data applications, but their real-world use cases highlight their strengths. PyTorch is the go-to framework for cutting-edge research in areas like computer vision, natural language processing, and reinforcement learning. Many academic papers are written using PyTorch because of its flexibility. TensorFlow is heavily adopted in industry for production-grade applications, such as recommendation systems, fraud detection, and automated speech recognition. TensorFlow Extended, TFX, and TensorFlow Serving make it easy to deploy and manage models at scale. So, which framework is right for you? If you're focused on research, experimentation, or academic work, PyTorch is the way to go. Its flexibility and simplicity make it the ideal choice for trying out new ideas. On the other hand, if you're building production-grade machine learning pipelines or working with enterprise-scale big data, TensorFlow may be a better fit. Its powerful tools for deployment and scalability are unmatched. Ultimately, both frameworks are excellent, and the best choice depends on your specific use case. If you enjoyed this video, don't forget to like, subscribe, and let us know in the comments which framework you prefer, PyTorch or TensorFlow. Thanks for watching, and see you next time.